Hello everyone, welcome to CSE Core Concepts in my series of data structures. Today I am going to discuss about a non-linear data structure called as graphs. In my earlier videos I have discussed about the linear data structures, namely arrays, stacks, queues and linked list, and also I have discussed one non-linear data structure such as trees. Now we are going to discuss about graphs. So before proceeding with the graph, different types of graphs and all, I want to discuss about a definition mathematically how we define a graph. So basically, what is a graph? It depicts network modeling among the nodes. Where will it be used? Right. Now let us say, for example, if a airlines company want to show pictorially that how does the network of their flight is there, like from which cities to which cities they have a network. So for that case you can use a graphical type of a structure to depict, because this is non-hierarchical. What is the difference between trees and graphs? Trees will depict a hierarchical relationship, but when your relationship is neither hierarchical, okay, neither it is linear, but you want to show a network type of a structure, then it can be represented using a graph. You want to show the network how is in your LAN network you want to show for your lab. How will you depict it? Is it a hierarchical relationship? Of course may not be always, because server to client, but if there are multiple clients, you want to show the distribution of the network among the clients, then it is a your network relationship, right? So to depict this type of relationships, like a network type of a structure, you want a graph, right? So a graph is basically contains two sets. Let's say a graph G contains two sets V and E, where V represents vertices or nodes, finite, non-empty. They are finite. You cannot have infinite nodes in a graph, okay? Neither you can have here a non-empty, means non-empty means they have to have some values, right? And E is the set of edges. Edges means what? The lines which are connecting two nodes. So in this graph you can see the set of vertices, which are the vertices A, B, C, D and E. Let's say this is a representation for a airlines company. So A represents New Delhi. From New Delhi, say B is Bombay. So from New Delhi to Mumbai they have flight. From New Delhi to Bangalore they have flight. From New Delhi to, let's say, Kolkata they have flight. Now C, suppose it's representing Kolkata. So Kolkata to New Delhi, that is D. Kolkata to another place, let's say Chennai, E. Okay, so this is depicting how the network is being shown. And what are the edges here? The lines which are connecting the nodes. So the first edge is A to B, second edge is A to D, third is A to C, C to D and C to E. So how many vertices are there here? There are 5 vertices. And how many edges are there? 5 edges are there. Okay, now this these edge, if two nodes are connected via a single edge, that those two nodes are called as the adjacent nodes. So here A and B are adjacent nodes. Now in this graph you can see there are no arrows. The lines are simple straight lines. What does it mean? That the connectivity from A to D and D to A is there. Both implies. So these type of graphs are called as undirected graphs. Okay, they are not showing any specific direction. Whereas here you can see that from A to B I have a single line arrow. So this is a directed graph, or they are also called as a digraph. Now if I am putting some weightage, okay, from beyond the edges, let's say the weightage I am giving 5 to some edge, 6 to some edge, okay, depending on the importance or depending on the cost. Let's say, for example, this graph is showing the network channel. Say I want to distribute milk via a truck, right? So when I am going through, so the cost of going from one place to another, I can mention it on the edge, right? So based on that cost I can develop my route. Okay, I can figure out my route, that which route will give me less cost, right? So that cost can be on the edges, okay, or some weightage I can give on the edges. So such graphs which have some weights on the edges, they are called as a weighted graph. Now sometimes there is a looping in a graph, that means there is a route from that node to that node, like from B to B. Okay, there is again a route, that is called as a loop. Now there are other mathematical descriptions. Let's say I have three descriptions we are discussing here: in degree, out degree and degree. So here in this graph you can see there are 4 nodes and all the edges are directed edges. So that is a digraph. This is a digraph. Now U to V, there is an edge from U to V and from V to U. So for each node I can have in degree and I can have out degree. What is an in degree? The number of edges directing towards that node. So if I talk about V, how many edges are going towards V? Only one, which is originating from U. Okay, so the in degree of V is what? 1. Now out degree means how many edges are going from that node. So from V you can have 2 edges which are going out, that is U and W, right? So the out degree of V is what? 2. So if you add both of them, in degree and out degree, that will give you the total degree of that node. Understood? So in this case for U, consider the node U. How many in degrees are there? 2 in degrees. One from V, one from X, right? 2 in degree. But out degree is only 1 towards V. So obviously the degree of U is also 3, right? Now if you consider W, for W in degree is 2 and out degree is 1. So for W also it is 3. For X also out degree is 2 but in degree is only 1, right? So again 3, fine. Now if you consider this graph, okay, and from this graph I want to derive a matrix, right? I want to give, instead of a graph, I want to show the relationship using a matrix. So how should I? Now this is what type of a graph? Undirected graph, right? There are no arrows here. So A to B. Now how are you going to form this matrix? In the rows and the columns you are going to write down all the nodes A, B, C, D, E, both in the rows and columns. Now is there any looping between A to A? Is there any path from A to A? No. So from A to A the relationship is 0. Then from A to B, yes. So if there is a relationship, you will write 1. Now since this is an unweighted graph, there are no weights written on this graph, we are just representing the relationship with the value 1. Now assume that there is some weightage given to the edges. Okay, then in that case you are going to write the weights in the matrix, right? Now from A to C, yes. From A to D, no, there is no connection. Then from A to E, yes. Similarly from B to A there is a connection because it is an undirected graph. So both ways it is there. From B to B no looping is there. From B to C, yes. B to D and E, no. C shares its connection with A, B, D and E. With everyone C is connected except for itself since it has no loop. With D it is only with C. With E it is only with A and C. Okay, so this way you can derive a matrix. This is called as an adjacency matrix because this matrix is representing which nodes are adjacent to each other. So if you look at the first row A is adjacent to which nodes? B, C and E. Understood? Because it is sharing its edge with only these 3 nodes. So, understood? So this is how we can form the adjacency matrix. So this is about the introduction of graphs. In my next session we are going to go in much more detail about graphs and we will see the different methods or to find out the minimum spanning cost, or we can find out the minimum shortest distance. We are going to discuss about the various methods. So please don't forget to like, share and subscribe to CSE Concepts, and for more such informative videos please press the bell icon so that you can get the notification. Thank you.